Observing an arrow in flight, our senses tell us it travels smoothly to a target. But when we subject that flight to the strict laws of mathematical logic, the concept of physical movement stalls entirely. The thinker Zeno of Elea did not build physical theories to explain how the universe worked. He built logical mechanisms designed to demonstrate that the very idea of motion contains unresolvable contradictions. His method relied on taking a mathematical concept, infinite divisibility, and forcing it onto finite physical space. By turning quantitative geometry against our sensory experience, he sought to show that reality, as we commonly perceive it, breaks down under logical scrutiny. Consider moving a body from a starting position, point A, to a destination, point B, within a limited amount of time. This geometric diagram shows the path. To reach point B, the body must first arrive at this halfway mark. Logically, traversal requires completing the first half. But it must first reach the quarter mark, then the eighth, the 16th. This division continues without end. Zeno established a postulate for this series. Any two distinct points in space will always have another point separating them. Because space is infinitely divisible, any finite distance contains a mathematically limitless number of intervening points. Yet a moving object is given only a finite amount of time to reach its destination. It is impossible to complete an infinite sequence of tasks in a finite duration. Under this strict continuous model, physical travel cannot even begin. This raises a historical question. Did Zeno literally believe walking across a room was impossible, or was he executing a specific rhetorical strategy? Here is the classical bust of Zeno. Both Plato and Aristotle describe him not as a conventional natural philosopher, but as a pioneer of eristic disputation, or the art of contradiction. His mentor, Parmenides, argued for a strict monism, that reality is a single, unchanging entity. When contemporary intellectuals mocked this idea for contradicting everyday experience, Zeno deployed his paradoxes as retaliatory strikes. He utilized reductio ad absurdum. By adopting his critics' own basic assumptions that multiple things exist and move through space, he systematically derived results that were far more absurd than Parmenides' monism. These arguments were hostile logical traps. By forcing intuitive beliefs about distance and time to yield blatant impossibilities, Zeno demonstrated that his opponent's perception of ordinary reality was mathematically incoherent. If treating space as an infinite continuum leads to paralysis, Zeno showed that adopting the alternative model of time is equally fatal. In his arrow paradox, Zeno relies on the supposition that time is not a flowing stream. It is constructed out of indivisible instants, or discrete nows. Within any single indivisible instant, duration does not pass. This animated diagram visualizes a flying arrow at a single point in time, t. It occupies a space exactly equivalent to its own length and width. Zeno states whatever occupies its exact dimensions is at rest. Therefore, at instant t, the arrow is resting. Because this model dictates that time is entirely composed of these isolated instants, the conditions at t apply to every single instant of the arrow's flight. The arrow never moves. What we perceive as flight is a mathematical sequence of perfectly static states. Momentum is completely erased. Zeno introduces a third trap targeting relative motion, known as the stadium or moving rows paradox. This diagram shows 3 block rows. Stationary row A. Row B begins from the middle, row C from the end. Moving at constant speed in opposite directions, the leading B block passes 2 A blocks, but simultaneously passes 4 C blocks. Aristotle noted the assumption here. If a body travels at a constant velocity, the time required to pass identical objects of equal size must dictate the mathematical calculation of the time elapsed. By equating the time it takes the leading block to pass 2 units with the time it takes to pass 4, Zeno derives the mathematical conclusion that a given amount of time is equal to its double. Whether you model the universe as infinitely divisible or construct it from discrete blocks, applying strict quantitative logic shatters the coherence of physical motion. These logical traps created an immediate crisis for Greek natural philosophers attempting to map the physical world. The early atomists, Lysippus and Democritus, rejected Zeno's principle of infinite divisibility entirely. They theorized a universe built on absolute, indivisible physical units, specifically to bypass his paradoxes. Conversely, Anaxagoras accepted the premise of limitless divisibility, integrating the infinite into his own strict theory of material composition. Zeno forced Greek thinkers to abandon simple chemical models and construct complex physical theories, defining exactly how objects occupy spatial expanses. He proved that basic intuition is a weak foundation for physics. True scientific inquiry requires rigorously defending the mathematical behavior of the continuum down to the infinitesimal level. Modern mathematics uses limits and calculus to model infinite series converging into finite sums. Yet the underlying ontological problem, the strict physical reality of traversing an infinite number of gaps, remains a subject of rigorous debate. Look at this silhouette of the frozen arrow. Zeno's dialectic stands as a demand that we logically justify why a physical universe is permitted to move at all. Until the mathematical contradictions of the continuum are definitively resolved, pure logic dictates a state of absolute stasis.